The standard deviation is our most important measure of variation. So let's take a moment here and summarize what we know about the properties of standard deviation. It measures the variation among the data values, uses all of the data values and gives us a measure of variation among all of the data values. When values are close together, we have a small standard deviation. As they're clustered together, they're closer to that mean, that measure of central tendency. There's going to be less difference when we take each x minus x bar. Those numbers will be smaller if these are all clustered together. So values clustered together have a smaller standard deviation, less variation in the data. The standard deviation has the same units of measurement as the original data. And we said that's very important. In many data sets, a value is considered to be unusual if it differs from the mean by more than 2 standard deviations. So we calculated our minimum and maximum usual value by going out 2 standard deviations. So anything that differs more than that, either lower or higher, is considered to be unusual. And we can only compare variation in 2 data sets if the data sets use the same scale and units and their means are approximately the same. So we can't just randomly compare standard deviations. We have to have data sets that have means that are approximately the same, and we've used the same scale and units in our measures if we're going to do a comparison.